Now we're just using the figures from Dairy New Zealand on an average basis, because levels of calcium and magnesium and that may range anywhere between 20 and 40% variance. So we're just taking the medium, and I've used the figure of 1,000 kilograms of milk solids per hectare based on a grass system. Anything else you can extrapolate it higher. If you want to go 1,400 kilograms of milk solids, you can just times the figure by 1.4. So, but I just want to give you an idea now, like how small the quantities of nutrient that actually are leaving the farm through production. So like we have 12 kilograms of calcium that leave the farm in milk each year. Now that equates to 36 kilograms of limestone. And we have potassium, 10 kilograms of potassium. Such small quantities, 4 kilograms of salt, 1 kilogram of magnesium, that's equivalent to 2 kilograms of magnesium oxide, and 7 kilograms of P. Now what we have to look at is going, hold on, there are many ways that we can replace these products, or the variations of these products might be utilised in different manners to get the minerals that are required by the biology in the soil and the plants, the cows, and then ultimately what goes in the vat and then goes off for human consumption. So like for the calcium issue, we might have a lack of calcium, but if we've got plenty of silica and there's some carbon in the soil, that might be replaced by, that might create the calcium. And if we have lots of calcium, we have not enough potassium. Calcium minus hydrogen equals potassium. And so like if we need a bit of sodium and there's plenty of potassium, we've got potassium minus oxygen equals sodium. And the same, magnesium, calcium plus oxygen equals magnesium. Calcium minus oxygen equals magnesium. And phosphorus, silica plus hydrogen equals phosphorus. So the scenario is, what we're looking at is that there are many ways for the nutrient to be created, changed, and it's a very versatile process when you've got a really good biological system. So when we talk about that, that biological system requires energy in most of these equations, and that's where we see the electrical part of the soil sample coming in. So in all of this, what we need to take into the reality of the situation is we need to keep testing and we need to keep measuring. And it isn't a case of just lumbering more product onto the land. Like if we look at the phosphorus example here, is like if you have low phosphorus availability, you can increase phosphorus availability by applying a silica fertilizer. If you put the silicon on, it may very well create the phosphorus through plus 1 hydrogen equals phosphorus. There are so many variables, so what you have to look is at the soil test, the totals. Like in most cases, we have a massive amount of phosphorus in the soil that's not being utilised. So to get that into an available form, we would just use some silica. Now, if you've got 6 or 7 tonne of phosphorus per hectare, which many farmers do, that's 1,000 years of P at 7 kilograms a hectare. Now, I can guarantee that if you're running a good biological system and applying the relative nutrients, the part that kick-start the biology, keeps the energy flowing, keeps the trace elements up, that there's no way that soil P will actually be depleted in that manner. In fact, so quite often what we've seen is slight increases of levels. So the scenario is, what we've seen when you put this process together and understand the amount that's leaving the farm, it's the system that you operate in the soil that can be converted to an electrodynamic biological system that creates the nutrient that is you required to create the minerals, and then that creates the feed for the biology and for the animals and so on. So if you're looking at a potassium issue, for instance, it's much cheaper to put limestone on and a lot safer to put limestone on and create the potassium that way. It's huge cost saving. And it's the same with sodium. Sodium's quite cheap compared to potassium. You may add in a little bit of sodium. And you remember, this works in reverse too. Sodium plus oxygen equals potassium. That's another way that we could go about the issue. But the reality of it is that we need to have balance and let the soil and the biology work together. Now, the biggest function of all of this is that the plant that is growing, pasture, the kiwi fruit, whatever, the exudates that come from that plant into the soil through the biology is more or less informing the biology in the soil what is required for its best production. So now I've seen where people say you need more potassium to grow grass, and yet I see adequate potassium in the plants with massive production when the potassium level is only 1.5 to 2%. There's no lack of potassium in the grass. We like to see the potassium double the amount of calcium in the plant. Now, if you lump lots and lots of potassium on, you'll end up with 3 to 4 times the amount of potassium you have calcium, and you've got major health problems. But what we've seen is as things get in order, you start getting your base saturations right, you get the biology working right, that those trace elements all start to, the elements and the trace elements all start to go into an order that is very beneficial to the animals. And then when that changes, the reaction with those animals is that they don't require supplementation, they don't have any health issues, and then the milk that's produced from this doesn't create scours in the calves, and then you have issues like when you're making cheese at the factory, you don't have nitrates levels very high because everything is in balance and the biology is sorted out for you. Now, when you look at all of these cost factors and you put it together on your cost effectiveness on your farm and the productive levels, you start to see a massive widening of profitability against input costs. Now, you might not do the 1,400 kilograms of milk solids a hectare a year, but actually the amount of input to output and cost that you get and profit at the end of it can be 3 to 4 times greater. So the scenario is you need to do your figures and understand this process, but you also need to monitor it right from the very go. Right from the very soil sample, the very first time you do this, the carbon sequestration test, you monitor this, and then you can understand what's going on. And so when people turn up, like the fertilizer agents, and say, look, you need to put on 60 units of P a year to actually keep ahead of the game. Where did the rest of the phosphorus go, considering you only needed 7 kilograms? And if you'd done your testing and seen that you had a massive supply in the background and knew that you could actually create it, or that you might use a little bit of that supply in your production for next year, why would you go out and spend more money? Because most phosphorus products now are very high in cadmium and fluorine and arsenic. So they knock off biology. So if you buy these products and kill the biology with the heavy metals, then we actually have some major issues. Now, part of this process, understanding how the biological transmutation works, is given that if the toxicity is not too large, they've done these in trials where they've set up toxic waste and they've put in biology and put in electrical current, and they've measured heavy metals in these waste material that they need, and they've actually gone back, like lead and arsenic, cadmium, and they've gone back afterwards and found they couldn't find any of these heavy metals. So the biology is actually able to enhance or change its environment to what's satisfactory and healthy for itself. So this can happen in our soils. We can actually break down those toxins and we can get everything working for ourselves. And the greatest thing of all, we end up producing a fantastically good product which people want and require in good nutrition, and we're going to make more money, of course, but we also live in a fantastic environment which is really, really healthy for us. And it's a lot better for the community, a lot better for the waterways, and it ends up with a lot better fishing for us all. So we can enjoy our spare time that we make.